You can hear me clearly. It's 4 o'clock and it's just about kick-off time for Chelsea and Liverpool in the FA Cup back in the UK. So we have to get this done pretty quickly because I want to go and see the game. Anyway, never mind. Let me tell you about this revolution that you're about to see with the Highcon Euclid. Let me explain to you how folding carton production is about to change, how you will make boxes differently in the future. I want to explain a little bit to you about Highcon, who we are, what we do, our background, coming from the origins of Indigo, and being born out of a digital mentality where waiting for things for days isn't acceptable. Waiting for minutes might be acceptable, but days, no. We need systems which can produce quickly, instantly, and dynamically. We want to be able to change layouts and designs immediately. Up until now, packaging has relied upon its graphical changes to give you different styles of boxes. You want to change something, you have to change the graphics. Otherwise, we're talking about tooling changes. Now, we can change the entire style of a box immediately, within moments. I'm going to walk you through that and go through that. We'll do a full make ready on the machine. My colleagues here, Alex and David, will make a test on the machine. We'll run some sheets for you, and then at the end we'll pick up some of the samples and you'll see just for yourselves exactly how revolutionary this process is. Okay. During the process we'll be running one of the tools which you'll see live on the screen up here shortly, so at some point you'll get to see that. But I think it will be interesting just to go through that. I'll present the machine to you just in a moment. But first of all, I have a question. Who here in the audience is producing folding carton packaging with less than 10,000 sheets? Must be some people here. Up to now today, we have more than half of our visitors that are producing some production runs less than 10,000 sheets. And it's amazing how short the production runs are getting. Shorter and shorter, higher degrees of variability, more complex designs. I'll explain to you just the basic principles of the machine. We're starting with the feeder. We have a standard industry 3B feeder. That's something that I think you know very well, you're very familiar with it. You can see this type of feeder on many of the offset machines running at very high speed. Each individual sheet, which has been pre-printed in either digital or offset, will arrive down onto the feed table where we have a vacuum transport and a side register mechanism. The sheet is then arriving into our principal and core technology we call DART, D-A-R-T, Digital Adhesive Rule Technology. Exactly as you can see above me now, it's happening live on the machine. Just inside here, we have an individual foil. This is the foil here, which we've pre-positioned onto the upper cylinder. And then with the writing head from the dart, we write the creases. And it's exactly what's going on right now. So we have a canister of polymer, which is here, and this would actually write physically with a liquid polymer all the creases that we need to do. The information it's using is the information that you sent to it previously, which was a DXF file, coming from an ESCO type artwork or many of the other proprietary software suites. In the file, there are two layers of data, a creasing layer and a cutting layer. And all the information is sent to the machine here. It extracts the creasing information and writes the tool that you see above. The very important thing now, if you imagine, if you have many different jobs, once you've finished it in a traditional sense, you take a job out of an analog die cutter and you take this heavy piece of wood and go and store it in a storage somewhere. It's probably going to get rusty, it's going to get damaged, there's some re-knifing, there's cost and there's time to do it. Our warehouse is a hard drive here. All our jobs are stored here, all the parameters and all the settings. Substrates, coatings, everything in a library. Once we've gone into the dart system, we're carrying out the creasing with the upper tool that we see here. The sheet then is being deposited onto a lower pin bed, which holds the sheet and gives us a support underneath it. You can come up and see it afterwards. And then it passes into our next revolutionary technology, which is our 3 independent CO2 lasers. Each one is connected to an independent scanner. The scanner will scan 1/3 of the sheet and then control the laser, 400-watt laser, to cut the material of the substrate itself. We're cutting substrate 300 to 600 micron and a sheet size which is a full 3B sheet 1060-760. Once we've finished here, we pass the sheet right down to the end of the machine and into the delivery through a traditional down stacker. You've probably noticed that we've not carried out a stripping process yet. That's because we don't have one yet. And that's something that we're working on and we will have by the end of this year. The R&D guys probably just looked at me very strangely then, I think. Come on, I'm a sales guy, cut me some slack. At the end of the year, we will have the prototype for the stripping. Again, this will be a digital philosophy that we will incorporate into the machine. We do not want to have heavy tooling. We want to have a clean workflow going all the way through the machine. Quick summary then, how long have we been standing here? 8-9 minutes, and in 8-9 minutes we've received the file, uploaded it, made the tooling, got everything prepared, we're ready to make boxes. You've never seen that anywhere else before. The first time that this ever happens. It's revolutionary. I've been in this industry for 26 years, doing exactly all of these individual processes, and it was amazing the first time for me when I saw it. Highcon, as I said earlier, it's a new company. This is one of the first of 3 machines that we've developed here. These machines will be being shipped into Europe towards the end of this year. We have a limited number of machines for availability and a high uptake from customers. We're working with a letter of intent principle and also some customers which are paying down deposit to secure the machines for early next year. Please come up and talk to us about that afterwards because we know that we'll have some difficulty to fulfill all of the customer needs. I'm going to run the machine now, Alex, if that's okay. We'll produce some sheets and then please come up and have a look at them at the table at the end. Sheets are being picked up on the feeder now, coming down the feed table, being brought into registration. Rotary creasing for the first sheet, which is being passed now onto the lower pin belt, and then it will go into the laser cutting station that you'll see here. Scanned, cut to print, and then delivered at the end of the machine. Please come up and have a look. You can see much better when it's closer to the machine.